Hey everybody, I hope you're doing well. This is a continuation of the video on check digit scheme. In the first video, we talked about what an ISBN is, how to determine what the check digit is. I also gave you a small example of a transposition on how ISBN, the ISBN scheme, can detect that there was a problem. It won't tell you what the problem is, but it tells you something is wrong. At least you can go back and investigate that. I alluded to ISBN, that scheme detects all transpositions. So that's what I want to do in this video. So here's a quick recap of what we talked about in the last video. IBM scheme, it's a weighted sum where the weights are 10, 9, 8, and they go down to 1. And the last digit here, N, is the check digit. So if I switch the 5 and 2, I wind up getting a sum that is not congruent to 0 mod 11. I want to show you why this is always true for the ISBN scheme. Before we get started, I need to show you two theorems. One, if A is congruent to C mod M and B is congruent to C mod M, then their difference is automatically congruent to 0 mod M. And I'm going to leave that to you to prove. Theorem 2, and I think you might know this, that if P is a prime and P divides a product, the product AB, then either or both P divides A or P divides B. In other words, you can't split P up into two pieces. So these are two facts that I'm going to be using later on in the proof. So how are we going to set this up? Suppose I have an ISBN and I make a transpose. I want to show you that if that transpose number is still an ISBN, then the two numbers that we transposed, well, they were the same. So for example, they were both 5s, they were both 7s, they were both 2s. In other words, if the numbers were different, then something goes wrong. And so let me jump into the proof here. So there's a lot written down, but we're going to try to do this piece by piece. So I'm going to start with this. Suppose I have a number, A1, A2, A3. A3 is a digit. It's between 0 and 9. And I know ISBN has 10 digits, so I'm going to represent A by its digits. And I'm going to suppose that I have another number where I'm going to switch to transpose 2 of the digits. Specifically, I'm going to choose a digit and the one after it, AK and AK plus 1. So this could be like A2 and A3. It could be like A7 and A8. Now, I stopped this at 8 because this last digit, A10, that would mean K is 9. That's the check digit. I'm not going to transpose a check digit here. So here's a claim that B is an ISBN only if we wind up getting AK is equal to AK plus 1. So I want to prove this claim. So here's our buildup. A is a valid ISBN, B is a valid ISBN. If those two things are true, then AK has to be equal to AK plus 1. And that's the journey we're going to take right now. So if A is an ISBN, the sum, and this 11 minus I, it's a little mysterious, it's congruent to 0 mod 11. So, for example, when I'm writing this down, if I would write this whole entire sum out, I would get something like 10 A1 plus 9 A2 plus 8 A3 so on down to 1 A10. That's what the sum would be. Now, this is what we talked about in video 1. The weight of A1 is 10, the weight of A2 is 9. So if I have a subscript of 2, that would mean I would be equal to 2. 11 minus 2 is 9. So this is a nice convenient way to write this summation down. So we're assuming that A is a valid ISBN. Likewise, if B is a valid ISBN, and I'm going to change the A sub i's to a B sub I, I have the following sum is congruent to 0 mod 11. The next part of this is kind of using theorem 1. What I would like to do is to subtract these. But what's the only difference between A and B? Between A and B, it's only 2 digits. That's it. Everything else is the same. So when I subtract them, and you're going to have to do a little bit of work on your own on this, you wind up getting everything sums to 0 except for possibly AK and AK plus 1. So this part right here, this part, this is the remaining stuff in the number A, and this is the remaining stuff in B that doesn't match up exactly. AK, AK plus 1. Now, in B, I switch them, so I have an 11 minus K, 11 minus K. These two things are switched. It's switched in B, so I'm going to indicate that. Now, by theorem 1, I know that this difference is congruent to 0 mod 11. Doing a little bit of algebra, this whole entire expression simplifies down to this. You should check that out yourself. Now, since this is congruent to 0 mod 11, I know that this expression is a multiple of 11. But by theorem 2, since 11 is prime, 11 has to divide the first factor, or 11 has to divide the second factor. This is where things get a little bit interesting. What do we know about the number k? If we go back to the beginning of the proof, k is some number between 1 and 8. So does 11 divide any number between 1 and 8? It does not. So therefore, 11 has to divide this difference right here. So continuing on, I know that k is between 1 and 8, like I said, so 11 does not divide k. Hence, well, 11 has to divide that difference. But tell me about that difference. What is the largest AK could be? It could be 9. What's the smallest AK plus 1 could be? It could be 0. So what is the largest this difference could be? Well, I can actually do 1 better than 10, and I know the largest could be 9. When is the difference the smallest? When AK is at its smallest and AK plus 1 is at its largest. Again, I can even do better than negative 10 there. So now I have this expression is between negative 9 and 9. Well, think about all the integers between negative 9 and 9. There's not that many of them. What's the only integer between negative 9 and 9 that 11 divides? Does 11 divide 2? Does 11 divide 3? Does 11 divide negative 4? No. The only integer that 11 divides is 0. So the only thing that I can replace AK minus AK plus 1 is 0. And that's exactly what I wanted here. This tells us that AK and AK plus 1 are equal to each other, provided both A and P were valid ISBN numbers. So the claim is now proved. So what does this all mean? It says that if I have, I'm thinking of a contrapositive here, if I have two digits that are different and I switch them, then the resulting number can't be an ISBN number. ISBN, I shouldn't say number after that. And that shows that switching digits, provided the digits are different, produces a non-valid ISBN. I hope that was helpful. And I'll see you later. Stay safe. Bye.